Hi everybody, this is Mr. Murphy, and today I'm going to be taking you through worksheet 4. So this is our introduction to what are called our series, and we're going to learn what sigma notation is, which looks a little bit scary at first, but really is just a way that we can represent our series in a compact form. So it's not so bad once you learn what everything is and where it goes. So obviously the first two lessons of this chapter, you learned about sequences, you learned about geometric means, arithmetic means. You haven't actually learned what a series is yet. So by definition, a series is an indicated sum of the terms of a sequence. So instead of just finding what every single term is, you're now adding up all of those terms. So, a partial sum, if you were finding the first 20 terms, and you'd add up all 20 of those terms. The nice thing is we do have formulas for our series. You're going to learn those formulas next class. Today we're just going to talk about kind of how this is presented and a little bit of an overview of what it all looks like. So your arithmetic sequence, if we're looking down here, if we're given the sequence 9, 5, 1, negative 3, right? So if you're looking at that from the other day, you're probably trying to figure out what the common difference is. You're thinking, okay, what am I going to be asked? How does this relate to our arithmetic series? Well, we're going to use, instead of t sub n, t sub 1, you're going to see S sub n, S sub 1, S sub 2, stuff like that. So S sub 1 is kind of silly because it's just the first term, but it's saying the sum of the first term. So S sub 1 would just be 9 in this case. If we wanted to find S sub 2, that's saying add up the first two terms of the sequence. So S sub 2 is really just 9 plus 5, which would equal, obviously, 14. If we wanted to take it one further, S sub 3, we got 9 plus 5 plus 1. We're just adding up the first three terms of the sequence, and we get 15. So we could find any number of terms added together. That's going to be what our series indicates for us. So S sub n, just by definition here, it's the nth partial sum of a series. It's the sum of the first n terms of that sequence. So we're going to talk about, like I said, this class we're just going to kind of go over some of the notation. Next class you're going to learn some formulas for your arithmetic and geometric, and then down the road we're going to learn about what happens if it's an infinite sequence, if it goes on forever. So some different rules for all of that stuff, but we're getting a little bit ahead of ourselves here. So like I said, the series can be represented in a compact form using what's called our sigma notation. So what you're looking at, we've already been familiarized with some Greek lettering with alpha, theta, beta. We've seen with, angles back when you were doing SOHCAHTOA, stuff like that. You probably remember some of that. So our sigma notation, that's this weird looking E symbol. This is just more Greek lettering. But let's go through what all of this stuff is. So it's the bottom number, and I know this is using K. You'll see that sometimes in textbooks, or if you look things up online. K and N are essentially the same thing. So it's just the number of terms. So this is the bottom number is always the starting point. So it's saying you want to start with the first term, and this is the last term that you want to add up in your series. So it's saying if you wanted to add up the first 20 terms, you'd have a n equals 1 or k equals 1 on the bottom, and you would have a 20 up top. That's telling you what number term to end with when you're adding these all together. The last part, this t sub k or t sub n, is the formula. I'll say t sub n for the particular sequence that you're dealing with. So it's going to vary based on whatever the sequence is. You learned how to write t sub n equations in day 1 of this chapter. That's the value that goes in there. All this really means, though, when we're doing this stuff out, it's just saying we'd want to take t sub 1 plus t sub 2 plus t sub 3 all the way up to t sub n. We're just adding up all of the terms until we get to that ending point, that top number that's on top of the sigma there, the sigma symbol. So the challenging part with sigma notation is it obviously is new to us. It looks a little bit scary. The difficult part is it doesn't actually solve the sum for you. It doesn't give you the answer. It kind of just presents the entire situation. It tells you how many terms to add up. It tells you what the formula is for the sequence, but there's no actual, you're not actually deriving an answer out of it. That's what we're going to do more so with our formulas. Okay, if the numbers are small, like we see down here, we got a couple of sample problems, right? This is telling me that I want to start with my first term, and it's pretty much always starting with 1. Very rarely, if ever, is it going to say add up terms 5 through 10 or terms 15 through 30. So it's pretty much always a 1 on the bottom there, right? So this is saying that's our first term, and we want to add up to the third term. That's what we're doing, all right? If they're giving us this value, they're telling us 2 plus 5k, we can actually just plug these numbers in. So we can say if k was 1, what would that look like? It would be 2 plus 5 times 1. That would give us, that's basically saying use that formula to figure out what the first term would be, right? So if we did that out, that's obviously just going to be a 7, right? We want to add up all 3 of these terms. So our next would be 2 plus 5 times 2. That's just the formula used to get to our second term. So if we did that out, that would be 12. Plus, we only want to add 3 of them together. So 2 plus 5 times 3. We add that in. We obviously get 17 for that. So the sum of all of these, if we add up the 7, 12, and 17, that is 36. So the sigma notation told us, it kind of summarizes the problem. The actual sum of the first 3 terms is 36. Let's just do 1 or 2 more to kind of get the hang of this a little bit. The second one, again, we're adding up the first 3 terms. The particular formula is a little bit different here. We'll see, you can kind of see it already, hopefully, that this looks like it's more of a geometric thing. So if we just use our formula to get the particular term, so we got 2 times 3 to the n minus 1, so it'd be 1 minus 1, if I just kind of plug that in, plus, we'll simplify these in a second, 2 times 3 to the 2 minus 1, plus 2 times 3 to the 3 minus 1. Right, so if we simplify all of these, this is 2 times 3 to the 0 plus 2 times 3 to the first plus 2 times 3 squared. All right, if we simplify those, 2 times 3 to the 0 is just 2 plus 6 plus 18. So we can see that's geometric, right? We can see our R value is 3. We add all those things up and we get a sum of 26. The last one here, if you notice, it's pretty much identical to part B. The only difference is that 2 is now on the outside. So think about it for a second. Do you think it matters if the 2 is inside the sigma or outside of the sigma? So this is a little bit different. It's going to have the 2 all the way on the outside, and then we're just going to have 3 to the 1 minus 1 plus 3 to the 2 minus 1 plus 3 to the 3 minus 1. All right, so we got 2 times 3 to the 0 plus 3 to the first plus 3 squared. Simplify all of that, and we've got 2 times, let's see, we got 1 plus 3 plus 9. Multiply that all out, 2 times 13, we get right back to 26. So what that proves is it doesn't really matter if the 2 is on the outside or the inside. It would end up distributing through to all the terms and give you the same exact answer. All right, so it's good to understand that a little bit. Good to see how it would work out if we wrote this all out. With only 3 terms, 4 terms, 5 terms, we can use these methods where we just plug in the actual number of terms and find the particular term for each. If I said to add up the first 100 terms, you obviously wouldn't want to sit here and do this. You want to come up with formulas, which we're going to learn next class. Where this gets a little bit trickier is now taking a sequence that you're presented with and writing it in sigma notation. So obviously you need to totally understand this. First step is just to determine, is it arithmetic or geometric, which is really the first step on pretty much most of the stuff that we're doing in this chapter. So if we're looking at this, this is the same problem from above, 9, 5, 1, negative 3. Hopefully very quickly we can determine that this is arithmetic, and our D value would be negative 4. All right, so what's going on with our sigma notation? This number right here, they're telling us S sub 5. So S sub 5 equals. That's telling us how many terms we want to add up. So we're starting with the first term, and I'm going to put a 5 up top because we're adding up 5 terms altogether. The value that goes inside here is our T sub n equation. So we need to figure out what our specific T sub n equation is for this. So T sub n, right, is going to equal what? T sub 1. So we got 9 plus n minus 1 times that negative 4. We want to simplify this out as best we can. We got some like terms here once we distribute this through that we can combine. So we're going to have T sub n is going to equal, we're going to get negative 4n plus 4, so we're going to get 13 minus 4n. All right, this is the value we want to put into inside our sigma. That's what's going in here. So we'd have the 13 minus 4n. That's that simplified version for our particular T sub n for this sequence. Again, it doesn't solve our problem. It didn't actually give us an answer for the first 5 terms. If we wanted to, we could do what we did up here and actually plug in a 1, a 2, a 3, a 4, a 5, add those 5 things up. But this particular one is just saying write using sigma notation, so that would be our sigma notation. All right, S of the sum of the first 100 terms for this one. So we got 1/3, negative 1/6, 1/12. So anytime you're jumping back and forth between positive and negative, we should know that that has to be geometric. So we got geometric, and if we take a closer look at it, we're saying how are we getting from that 1/3 to negative 1/6? Our R value would be negative 1/2. All right. Write out our sigma symbol. We want to add up from the first term. This is telling us we're adding up the first 100, right? So we want the 100 up top there. And now we're just plugging in to our T sub n for our geometric. So our T sub n for our geometric, we've got T sub 1 times our R value raised to the n minus 1. And that is it. Geometric is actually a little bit nicer with sigma notation because there's really no simplifying that you can do. It's not like you can combine the 1/3 and the negative 1/2 because that exponent is there. So writing in sigma notation, you'll find geometric usually a little bit simpler because you don't need to simplify the T sub n equation that we're using there. So a lot of terminology today, even though, very short lesson, but a lot of different terminology to get used to. So just to kind of reinforce some of the material, the number that's on the bottom, that's always going to be your starting point, right? That's and pretty much always going to be 1. The number that's on top of the sigma is your ending point. So that's how many terms you want to add up. And then what's written inside there is your particular T sub n sequence. So should be an exit slip provided from your classroom teachers that you guys should work on. If you have any questions, please ask your teachers, and they can hopefully clarify. And then next class, you're going to learn some formulas that's going to make your life a lot easier once you start actually finding some of these sums, once the sums get a little bit larger. All right, thank you very much, and have a good day.